3-2 linear functions. Every linear equation has a related linear function. We use function notation to write the related function. So now instead of y equals, whenever they ask you to write a function notation, it will be in the form of f of x. You can either read it as f of x or the function of x. Evaluating functions. To evaluate functions, replace each x with the value given, then perform the operation. So -3 is the value that you are inputting, and you're finding the output. So the function of -3 equals to 4 times -3, which is a -12, and then same sign, add and keep the sign. The function of -3 is a -21. So when you input -3, your output is a -21. The second one, this function of -3 equals to a -1/3 times a -3 plus 5. Negative times negative, positive 1/3 of 3 is a +1 plus 5. The function of -3 would be a +6. The last one, f of -3 equals -2 times -3 minus 1 plus 3. Using your PEMDAS rules, do what's inside parentheses first. -3 minus 1 is a -4. -2 times a -4 is a +8. And then +8 added to a +3 is a +11. Next, identifying whether a table is a linear function or not. Linear functions have a constant rate of change. That constant rate of change is otherwise known as your slope. So looking here, your x's are going up by 5s each time. The y's are going up by 15. And then when you do slope formula, it's your y2 minus your y1 over x2 minus x1. So y is on the top, x is on the bottom. So if I were to simplify this, it would be 15 over 5. So my slope would be a 3. So since I have 15 over 5 each time, this does have a constant rate of change. So this first table is linear. This next table, adding 1 each time to your x's, but then your y's, from 1 to 4, it goes up +3. 4 to 9, +5, 9 to 16, +7. Since this is not a constant rate of change, this table is not linear. Now, if something is linear, you can now make a function notation in slope-intercept form. So you find your constant rate of change or your slope, and then you can either do a shortcut to find your y-intercept if it's easy enough, or you can use slope-intercept to help you find your b. So here, number of bracelets and each cost. So my bracelets are going up by 1. My y-intercept, my y's are going up by 15. 15 divided by 1 is 15. So my slope is 15. Remember that your y-intercept, whenever a line touches the y-axis, that ordered pair is always 0, y. So if I want to find my y-intercept, I can use one point. Let's say I can use 1, 17. And using my slope that I just found was 15. F of x is the same thing as y. So 17 equals my slope of 15 times my x value, which is a 1, plus b. 15 times 1, 15. Subtract 15 to both sides, and 2 equals b. So now f of x equals m, which is my slope, 15x, plus my b, which was a +2. So this would be my linear function for this table. You can also do a little bit of mental math. If I know my y-intercept has to be at 0, I can go backwards, and 17 minus 15 would be 2. 2 plus 15 would be 17. So 0 bracelets, why it's $2? It could be the materials that it cost to make the bracelets. Number 8, find your slope. Each x goes up by 1. Each y goes up by 6.5. 6.5 divided by 1, my slope is a 6.5. Again, you can use one ordered pair to help you find your b. So f of x, 6.5, equals m, 6.5 times 1, plus b, that's 6.5. Subtract 6.5 to both sides, and b equals 0. So f of x equals 6.5x. I don't need to put plus or minus 0. Again, you can also work backwards. Y-intercept is whenever x is 0. Go backwards and subtract 6.5 from 6.5, and it should be 0. And this should work. Next, comparing functions. To compare functions, focus on key features of the linear functions. Find your slope, y-intercept, domain, and range, and then compare them. So here we have two functions. We have f of x, and we have g of x. So my slope of f of x is 2, always the number that's next to x. My y-intercept is 5. Since this is a linear function, my domain will always be all real numbers. If I were to graph this, this starts at 5 on the y, it goes up to 1 to the right. So f of x would look like this. Since my arrows are going up forever and down forever, my range would also be all real numbers. Next, let's do the table. G of x. My slope here, this is going up by 1. My y's are going up by 3's. 3 divided by 1, my slope is 3. And then the table is giving us the y-intercept. Whenever x is 0, that number for y is your y-intercept. So that is where it touches the y-axis. Again, if you were to graph this, 0, 4, and then 1, 7, 2, 10, 3, 13, this also, since it has a positive slope, would also be pointing up from left to right. So my domain would be all real numbers as well. And my range, the y's go up and down forever. All real numbers. So how do the slopes compare? F of x has a slope of 2, g of x has a slope of 3, so g of x has a greater slope. Letter B, which function has a greater y-intercept? F of x has a 5, g of x has a 4, so f of x has a greater y-intercept. Then, if the domain are both real numbers, compare the ranges. Both ranges are also all real numbers. All right, some higher order thinking. Consider the functions g of x and h of x for the domain 0 is less than x, which is less than 5. How do the ranges compare? Well, g of x starts at 1, h of x starts at 2. So no matter what, h of x is going to increase each time by 1. So h of x is greater by 1. And now we have to graph the two functions and describe their intervals. All right, starting with g of x. The smallest domain is the 0, so that's the smallest input that is going to be going in. 2 times 0 is 0, plus 1 is 1, so this would be kind of 0, comma 1. The greatest domain would be 5 going in, so g of 5 equals 2 times 5 plus 1, 2 times 5, 10, plus 1, 11. So this would be 5, 11. Because they do not have equal signs, they will have open circles. So 0, 1, 1, 2, 3, 4, 5, 11 should be right here. And then a line from point to point. So then this range would be 1, then g of x, that's my range, less than 11. Well, I know h of x is greater by 1, so that should be 2 to 12, but we can just do the math. 2x plus 2. Again, smallest domain is 0. H of 0 equals 2 times 0 plus 2. H of 0 equals 2. H of 5 equals 2 times 5 plus 2. 2 times 5 is 10, plus 2 is 12. So 2 is less than h of x, which is less than 12. Oh, no. So open circle at 2 comma 12, and then right on top of it there. That's what the graphs would look like. Number 10, a function f of x equals 4x plus 5 has a domain of 0 is less than or equal to x, which is less than or equal to 50. What is its range? So 0 is the smallest domain. So f of 0 equals to 4 times 0 plus 5. 4 times 0 is 0, plus 5 equals 5. So when x is 0, y is 5. So 5 is less than or equal to f of x, which is less than or equal to f of 50 equals 4 times 50 plus 5. 4 times 50 is 200, plus 5 is 205. So the range would be 5 is less than or equal to f of x, which is less than or equal to 205. 11, for a basic subscription, a cable television provider charges an activation fee of $60, a one-time fee, plus $125 per month. What would be a linear function that represents the total cost of basic cable subscription for T months? So f of t, very important that would whatever variable you use inside here has to be the same variable on the other side. 125 per month plus a one-time activation fee. Now be careful. What is a total cost for 2 years? But T represents months. In 2 years, 12 months out of the year, that would be for 24 months. So f of 24. So 125 times 24 should be 3,000, and then 3,000 added to 60 would be $3,060. And there is going to be a part 2 for 3-2. which should be right here. Solving simple interest problem. Simple interest has the formula A equals A of t equals P times 1 plus R times t. A of t, t represents the total, A of t represents the total amount. P is the principal, how much you are investing. Principal. R represents your interest rate, written as a percent, decimal, and t represents your time. So write a linear function that models the situation. So A of t equals, he invested $450 times 1 plus 4% written as a decimal is 0.04. Divided by 100 or move it over 2 decimal places. So 0.04, and then letter A just wants us to write a linear function, so don't worry about the 6 for right now. We're just representing time with the variable t. So that would be letter A, writing a linear function that models that situation. Now we have to solve it. How much money is he going to have after 6 years? So A of 6 equals 450 times 1 plus, I like to use brackets, 1 plus 0.04 because I have parentheses now here. So then work inside out. 0.04 times 6 is 0.24. Add that to 1 and is 1.24. And then multiply that by 450. And at the end of the 6 years, Paulo would have $558 invested in his account. Here's another example. Benson and Tanya invested their money into 2 different opportunities shown in the right. Who would have more money after 4 years? So again, here's my formula. This formula is provided for you on the reference sheet of the EOC. So Benson, after 4 years, he starts with $400. 1 plus 5% as a decimal is 0.05, and I want to know how much he's going to have after 4 years. 0.05 times 4 is 0.20. Added to 1 is 1.20, and 1.20 times 400 is $480. Then we have Tanya. She starts, well, still also 4 years, she starts with $350 in her account, but her interest rate is at 6%, so 0.06. So 0.06 times 4, 0.24, time plus 1 is 1.24. So after 4 years, Tanya is going to have 1.24, $434 in her account. So after the 4 years, Benson would have more money in his account. And that is 3-2.